Well, hello everyone. So this is my second video and I want to show you something which is the other side of my hacking, web hacking. So I'll show you something I did. But first let's go to an article I saw. So I was trying to execute some JavaScript just before someone leaves my web page. I was doing this research, right? Then I came across this thread on Stack Overflow. The person is actually asking the right questions here, how to execute JavaScript code. Then I come here, this guy answers by saying these events on onload and on before onload cannot redirect the user to another page. For this is for security reasons, and if you want to solve blah 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 blah, yeah, I just got bored because this last sentence killed me. For security reasons, why on earth would you do this to me? And then I started thinking, is it now possible for me to come and redirect this even though it says it's for security reasons? Yeah, sounds like a challenge, and I love challenges. So I went ahead and I wrote this code. Pretty simple, 65 lines of HTML. What could go wrong? Well, basically, let me give you a rundown. We'll set a timeout for 4,000 seconds. Sorry, 4,000 milliseconds, which is 4 seconds. Then we set a value stop to true and then alert leaving. Now this is a timeout we set for 100 milliseconds before we execute this, and inside is an interval where we create a for loop which checks if this stop actually is true. This I was never set to anything, but since it's an or case, either of these will trigger this here code. So if stop, then we clear the interval and open site2.html, which just says I am site2. Wonderful, pretty. That's how the website's supposed to act. But everything else that I'm going to show you happens outside this block. But before I explain the remaining of the code, let me show you what it does. Now we open the developer console just so that I can keep tabs on what's going on. Localhost. Now, yeah, a lot of messages, a lot of stuff is going on right here. It says we're leaving. Say wonderful, yeah, we're leaving the website. Site 2, here we come. Wonderful. Because hey, we don't want to visit another web page and the best resource or best source of knowledge known to man, the internet. It's wonderful, right? Yeah, let's go to another web page. But please just stay with me because this might actually take long to do. Now let's cross our fingers and hope this worked. Please. Yeah, this is taking a long time. I'll explain to you why, because this code I'm about to show you is actually designed to slow down the CPU so that whatever we're doing can be done. And here we are. Wait a minute, you are not supposed to be here. You'll be like, wait, yeah, I know some of you understand HTML and we said we're opening site 2. This is the code in site 2. It just says title site 2, I am site 2, and alerts an error if there's anything wrong. So why is it displaying wait a minute, you're not supposed to be here? Well, if you check the address bar, it says another.html. Now you might be a little more confused about this, because wait, open site 2, that's common English now. Yes, and it is. I'm glad you noticed. But now, is that what the code I wrote does? It goes around everything this professional said, because obviously this guy doesn't know his JavaScript, or maybe I'm just getting ahead of myself. But seriously, dude, for security reasons, yeah, maybe he's just trying to kill the spirits of a young hacker or something. Maybe he's trying to kill the spirits of this young hacker or anything. But dude, yeah, obviously what you said is no longer applicable, because I just did this. Now you may be saying, well, okay, it might be Firefox, that's why your code worked. Then let's try Chrome. Now Chrome is faster, so you see this going a lot better, and now you see the wonderful errors. Now we press OK, cross our fingers, and hope the exploit works. Yep, wait a minute, you are not supposed to be here. So what exactly is going on? What did I manage to do that completely circumvents what browsers are supposed to be like, what JavaScript is supposed to be like, what the internet is supposed to be like? Well, it's not basically about the internet, it's about how JavaScript actually works. Well, JavaScript is memory intensive and it's asynchronous, and when you have those two things combined, there's bound to be, I think, serious mishaps. So, well, browsers manage to keep things together, tightly woven together, by organizing themselves on how to clean up memory, stuff that are not being used anymore, how to do all those type of stuff. But I just want to put to you that every single process in this code has been made to instruct the computers. In this code instructs the computer to perform all these operations within 4 seconds, and I am running on 16 gigs of RAM right now. So you will need to understand that 4 seconds running some operations shouldn't be hard. But then I'll show you why this is crazy. What I did is absolutely crazy. So I come here. First of all, we've already discussed this part, so now let me separate this from here. The magic happens. Yep. So we create a fake character. What is a fake character? Well, S is a character, T is a character, everything there, real characters, right? So now let me explain to you how a character is being recognized by a computer. Well, everything is in pixels, X and Y, and each X and Y coordinate has 3 values, R, G, B. Now R for red, G for green, and B for blue. Now these are the primary colors, and you can construct any other color with these 3. So what it does is, for each pixel it assigns 3 values, which are the RGB, and now a display manager helps to control which values are put in which pixel, so that to create a letter. Like here, it has a black background for most of the pixels here, and then for this G, the specific pixels in charge of creating those G have been set to an RGB value to show yellow, which we see right here. So the characters, the shapes, the way they are organized are also represented in numbers, because that's all the computer understands. These numbers are the char codes, and there is a standard for it, Unicode. You can check that out. So Unicode has a range of numbers for you to show, and anything outside that can cause problems. So that's exactly what I did. I created random character codes. This is here, math.random times 100. Math.random is always between 0 and 1, so multiply by 100 gives me a value between 0 and 100, which is in a way good for character encodings, but in this case I'm looping 1000 times or 999 times. Haven't looked at this code well enough to figure that out. So, and then I get this element by id t and set and increment whatever it says inner HTML with this fake character. So now if I set a character to this guy, which is the element I just spoke about, if I just set a character to this guy, I can set another one which will increase, keep adding more characters to this guy. And let's not forget, I do that 1000 times and I create fake ones. And set them to color white so that it will be invisible to the user as it was invisible to us. So as you notice on the website, you didn't see any long paragraph or something like that. No, because I set the color to white. Because if I set it to visibility none, it wouldn't show, and then the display manager will not have to struggle with all these things. And the goal of this code is to make the CPU struggle and slow down a lot. So I did this to slow it down a lot, and then after, once again, slow it down by console.login things which will have to be showed on the screen. Then the best part ever, this call here, fetch. This website here can be any website. You just need to fetch a website, as in get the contents of a website. Because this fetch call is completely asynchronous, it causes more problems for your CPU, because you've already created random characters with the display manager or ask the CPU to take care of, and now we are also fetching websites that you're going to ask the CPU to take care of using the internet. You see, lots of stuff. And then we set the mode to cause, so that in case there is no header that allows it to make cross-origin requests, it generates an error which will catch here. And if it does not generate an error and that website actually allows you to make requests without that header, we then try to do something, evaluate the HTML as JavaScript, which will cause another error which will bring us straight back to here. So in both cases, if there's a header, get an error, no header, get an error. And then inside this error again, we try to make more UI elements to slow the display manager down even more, and also your CPU. Then we log error occurred and then set onload to this in case actually we have arrived inside 2.html. We can set onload to alert this, which will show that we've gained control of the second website. But if we can't do that again, what we'll try to do is check if stop is set to true, which means that we are trying to open this, and at that moment the browser is trying to clear out whatever mess we created before, which it will be doing by this point. Then we silently set a timeout once the browser is busy cleaning stuff up. It's like something, just it's already busy with doing something, and then you bring another thing, it won't notice it. It won't notice this. So before it tries to get around to clean this one up, the timeout which we've set to 1 second would have already been over, because all the stuff we generated here causes a lot of problems, lots of it. So as it's trying to clean those ones up, it will take more than a second. So whatever is in here will get executed, which is setting our path name to another .html, which redirects us to this web page, which explains a lot of stuff. Wait a minute, you are not supposed to be here. Yeah, it's a wonderful thing. And to even make things worse for the browser and the CPU in general, we set this interval to execute this same horrifying piece of code to an absurdly minuscule value, which I cannot even describe right now, because I just kept my finger on the 0 button until I was satisfied. So that's it. Does all of this to slow the CPU down so that we can control what happens in the next window, and that yielded wonderful results. Yeah, so thank you for watching, and I will most likely report this bug to Firefox and Google Chrome. Hopefully we'll fix it by the next release. Thank you.